Good morning, everyone. Okay, so we are meeting after a long break, and we have completed with our module of assignment problems. And with the completion of that particular module of assignment problems, where we have discussed about the Hungarian method, we are in the stage of half of the syllabus that has been completed. So now the entire module, if I can say briefly, then let me just first of all share the whiteboard so that there are the chances that few of the people may miss the talks. Okay, let me just erase it. Okay, so our course of optimization is entirely divided into two parts. That is the linear optimization and the second is the non-linear optimization. Now in this particular part of linear optimization, we have discussed about the linear programming problem methods, which included the graphical method or the simplex method, BGAM method, and the last one was the integer problem methods. Then we have discussed about the transportation problem, and then we have discussed about the assignment problem. So these are all the things that we have already discussed in our course of optimization that includes the linear optimization. So we are done with the first part of our course, optimization techniques. And now we will be starting with the second part of our course, that is the nonlinear optimization. Just hold on for a minute. I'm getting one of the call, so just wait for a minute. Okay, so we were discussing that, okay, we have just completed with our first part of our course of the optimization technique, that is the linear programming methods or linear optimization. And from today onwards, we would be moving forward for the non-linear optimization. So there would be the changes in some of the methods, there would be the changes in the approach to solve the problems, but ultimately our main intention, our final goal, our main task will be the same. There won't be any change in the final goal of our task. The final goal will be the same. The only change will be in the methods. The minor change will be there in all the methods. Now, since we have completed with this particular thing, and let me just again open the evaluation scheme. Okay, I hope the screen will be visible to all of you. So in this particular lesson scheme, we are having the two exams to be taken. We will be having the two exams. One exam will be the closed book exam, and the another will be the presentation of the research papers of optimization techniques. Now, I will be just telling which are the types of the papers you can just present, or you can even search in the Google about the types of the papers, but not today. I will be just telling it in the next week because today is not the right time to tell about the type of the papers, because I am more interested to have the declaration of this first part, that is the first ESE closed book test. So we would be having the closed book test for the linear programming methods. We would be having one ESE exam corresponding to this first part. Corresponding to this first part, we would be having one ESE exam. And that would be closed book test. So I haven't decided the date for this particular exam because this date won't be decided only by me, because I need to take the reference from other people also. The people will be including the Department of Faculties, because this exam won't get complete in 1 hour. So that is the reason I will be required to have the approval from the other faculties to have their lecture. Plus, I will be also required to have the things from when is your free time slot, or when your exams are not being scheduled. So these are all the things I will be just taking the note of, and then I will be conducting the closed book exam. But if anybody can tell me, just let's have a discussion for 1 or 2 minutes so that I can get your own views also. That how many days, the minimum number of days you will be requiring to prepare for all these things for your ESC component, for your first ESC component. Now the exam will be of 50 marks. Let me just tell that thing. Your exam will be of 50 marks. And it will be including all these topics from the very starting to the current time. I won't be including any of the content of nonlinear optimization in that particular exam. But till this particular point of time, till our previous session, all the content will be included. So how many days you want for the preparation? Just let me know that particular thing. Now don't just tell that we want 1 month of the time. I can't spare more than 2 weeks. And even I can't give you 2 weeks. So I just want to know from your side. Okay, minimum 1 week, 10 to 15 days. Okay. 10 days, 15 days. Okay, now so again, I am sorry because I told that I can't spare 2 weeks. So definitely it won't be 2 weeks, but I'll be trying to take the exam within the 2 weeks, or within the 2 weeks means I will be at least giving you 8 to 9 days for the preparation. The common response I'm getting is 10 and 15. So I will be sticking with minimum 10 days, maximum 14 days. 10 to 14 days will be the time from today when I will be taking the exam. So if you count it, then it will be in between 16 to 20. The dates of the exam will be in between 16 to 20. So mark this date. I will be just confirming when your exams will be there, and I will be just declaring within 1 or 2 days. But as of now, you can keep this date to be finalized, that it will be somewhere in between this 16 to 20 of this particular month. Okay, so I am getting one of the response that okay, you are having the exam of the Linux on 16 and 17. Okay, so that was the reason I didn't actually declare it from my side directly, because I need to consult with the other faculties so that you don't have the clashes in between the exams. So I will be just keeping the date like this, 18 to 20. You, in the worst case, I will be taking the exam on Saturday. In the worst case, and I will be giving you the leave on Monday for the lecture, because I do, if I don't have any of the solution, then that is the best possible solution that I can have. The Saturday I mean by 18th. So let's see, I'll be finalizing the date. It's 18, 19, 20. So it is nothing but Saturday, Sunday, Monday. So I'll be just finalizing the date and will be declaring to you. Okay. So anybody having any of the question regarding this particular declaration of the ESE component, the exam, the first exam? Okay, so I will be looking into the method that you get the sufficient time to write in the exam. See, to be frank enough with everybody, my intention is never like you miss some of the questions while writing the exam, despite knowing the entire exam, despite knowing all the things in the exam. My intention is never like that you miss some of the questions because of the time duration. My intention, I get more and more happy whenever the student scores marks. But along with the marks, I am also interested with the thing that you just speed up. So till now, the thing that were being considered were the class tests. Till now, I have taken only the class tests. And in the class tests, my intention will always like you speed up with the exam so that you can have the better grip over the questions. But in ESE, I won't be doing that particular thing. So don't worry about that. I will be giving you sufficient time. And even if you require more time, then I can extend the exam for few 15 to 20 more minutes. So don't worry about that. My intention will never be like that you miss some of the questions, you have loss of the marks despite knowing the questions. I know that this subject is easy, but it is very tricky one to solve. So don't worry, I won't be doing that type of the things in the ESE exam. But yes, I will be making you speed up during the class test. So in any of the subjects in your future also, in your future subjects also, I will be giving those type of the questions only, which will be dealing with the time-based constraints. But in the ESE, I won't be dealing in that particular manner. So don't worry about that. I will be giving you the sufficient time to write your exam. Any other things that you would like to ask me? Yes, the duration of the exam. One question was that as of now, I didn't actually set the paper till now, so I can't claim on the duration, but it will be around 2 to 2.5 hours, 120 to 150 minutes. The exam is of 50 marks, and I probably guess that this time is sufficient enough because because your university just provides you 3 hours for 100 marks paper. So I will be providing 2 to 2.5 hours for 50 marks paper, because in that particular thing you will be having 10 to 12 MCQs and all these things. So in this exam, I won't be dealing in that many number of the MCQs and 10 to 15 number of short answers like one sentence answers. No, I won't be dealing in that manner. Type of the questions, yes, I again I'm saying that I haven't set the paper. So I can't claim on the type of the questions, but I will be declaring the type of the questions and the exact duration of the exam in probably 4 to 5 days. Once I just fix few of the questions in my mind, at that time I will be just declaring the type of the questions. But tentatively, if I say, then the type of the questions will be few of the MCQs, few in the sense 3 to 4 MCQs, 3 to 4 short answers, then few of the logical based answers, and then the numerical based questions will be there. The case study based questions will be there. Any another question, anybody? We can spare 2 to 3 more minutes for this discussion, and then we'll be starting with the nonlinear optimization topic. The content will be till this particular point of time, till we have completed this linear programming problems. Okay. For the research paper, please give 20 days before so that we can go and detailing and understanding. Yes, don't worry, I will be giving you more than 1 month. That's what my claim is. I will be giving you more than 1 month. Today, I am not declaring the research paper because I don't want to give 2 things at a time. And those 2 things are the major things because ESE component plays a major role. So I don't want to give you 2 things at a time. The submission of the research papers will be there at the very end of the semester. Whenever your term ends, at that time it will be there. And I will be declaring about the research paper. I will be giving you the guidelines about the research paper. I will be discussing about the types of the research paper in the next week. So you can just have the tentative idea that you will be getting more than 1.5 months. Because probably I don't know about the term end, but probably it will be something around December only. I haven't got any idea about when your term will be ending, but it will be somewhere around the December only. Okay, for the nonlinear programming, would there be an ESE exam? No, I told that there will be 2 SE exams. First will be the written exam, and the second exam will be considered as a research paper solution. So there won't be the ESE exam, but yes, there will be the class test exam because we are also having the class test in our component. So it won't be like that none of the questions or you won't be evaluated based on the content which is being taught from now onwards. Definitely will be evaluated based on the content, but in the form of the class tests. One of the reason I actually didn't meant to declare it, but since the question is been asked that for the nonlinear programming exam, would we be having the ESE exam? One of the reason to give the research paper is that the real-time problems, the real-life scenarios are never linear. Remember this thing, the real-time scenarios are never linear. They are always non-linear. They are always dealing in the non-linear fashion. And hence, the research papers which you will be doing are the current research papers. That is, they are dealing with the current scenarios. So, based on the current scenarios, you will be given the research papers and you will be trying to solve this. So ultimately, it will be testing your nonlinear programming abilities also. Okay, so one of the thing is that the SEM will end around October. Yes, fine, that's completely fine. There is no issue in the time frame of the completion of the course because we are well on the track of the completion of the course. And yes, definitely you will be at least getting 1.5 months. That's what I can assure. Because every time I used to give this thing since in your seniors batches also I have given the same type of the strategy was being adopted in their batches also. So I am quite confident enough that you will be getting 1.5 months at least to have your research paper. Probably what is there in my mind would be of the first semester's batch when their exams will get complete in December. So don't worry about that. It's completely fine. Okay. Any further questions? Is the thing clear, everybody? Then we will be starting with our discussion of nonlinear programming. Okay, I'm getting the messages 4 to 5 messages till now that okay, it's clear. Okay, so let's start with the discussion of the nonlinear programming problems. As I told that the current real life scenarios are never dealing in the linear manner. They are always dealing in the nonlinear manner, and that is the reason I would be more preferring to discuss this thing, or I would be more preferring to check whether you understood the things correctly or not in the nonlinear programming through the research papers. And that is the reason I am giving you the research papers, or you will be selecting the research papers rather for this particular thing of the evaluation. Okay. So as I told that it is the real life scenarios that are dealing in the non-linear programming problems. And from this particular thing, let me declare one thing today, that from this particular discussion, your first step towards the field of ML AI starts. This is the first step towards your field of ML AI. Because in ML or AI, what you are actually doing, what is machine learning or artificial intelligence? So what do we mean by this thing? So actually, if anybody can say what is our main intention behind machine learning or artificial intelligence, so what is our main intention behind this field of AI? Can anybody just say, just have a discussion? We won't be going into the too much of the details today, but we would be having the essence of why nonlinear is very, very important. Okay, good answer given by Prerna. It's to find patterns and adapt the changes, correct? The answer by Viraj. Identify each and every stage and make the model work accordingly by the robots, correct? Karan has to say we are training our model based on the available data and then give output for the next or real-time input. Fine. So I will be just jotting it down over here. Work by robot. That means the automation, I can say something like that. Prediction based on previous data. Right? Predicting from existing model for the future input. Correct, Viraj? Zeal is to say to use the historical data to learn and generalize in order to generate predictions about new data. Correct? So I would be, so it is in this particular third point only, prediction based on previous data, but I would be using one word which he has mentioned, that is to generalize. Okay, so correctly given by you all, those who have just given the answer, that we are actually by AI. The AI term comes from, the full form of AI is artificial intelligence. So every time probably you might have heard from my side, or if you ask from your seniors batch, every time I would be saying why it is called artificial intelligence. The reason behind it is that humans have been given the essence of the natural intelligence. It is the intelligence in the human which has been gifted by God. So our intelligence is the natural intelligence. Now we are capable of making ourselves mold according to the changes that we are seeing. We are capable of adapting the changes. We are capable of working on our own intelligence. We are capable of taking the decisions. We are capable of looking into the data, looking into the analysis part, and we are capable of taking the decisions. But if I want the same task to be done by some robot or by a machine, then should I be asking or should I be praying God that please God give this particular robot the intelligence? Please God please God this robot should be given some intelligence because I want this robot to work on behalf of me. No. What I will be doing? I will be transferring the intelligence, the human intelligence to the robot. Now, transferration of this intelligence, the human intelligence to the robot, it doesn't mean that, okay, I would be just no, giving my brain or I will be just giving my mind to that particular robot. No. How we are transferring our intelligence, the natural intelligence, the intelligence that the humans are having to the robot, we are transferring it by making the robot learn something. Making the robot learn something. How actually you are developing the intelligence? Whenever we take birth, at that time we are not knowing that, okay, these are the some type of the things that will be faced by us. There are the certain subjects like, okay, problem solving using Python, the algorithm designing, the optimization techniques, or the artificial intelligence, or the machine learning that we will be facing somewhere in our life. We don't know about that. These are all the things that we learn from our seniors, from our teachers, from our peer mates, from our environment. So same thing, the robots will be learning from the peers. So the robots will be learning from the peers, from the environment, from the parents. So over here for the robots, the parents are nothing but the developers. From, you can say, by the programming. So these are all the things how the robots will be learning. How the robot can learn from the peers or from the environment. So you will be learning one important field of artificial intelligence, that is reinforcement learning. That is the transfer learning process. So what is the transfer learning? We have seen this type of the things that, okay, transfer learning. Google uses the transfer learning. What is this transfer learning? It is nothing but transferring the process of the learning part from one model one well-established model to a developing model. So this is nothing but the transfer learning. What do we actually mean by transfer learning? If I just say in more generalized form by giving the example, suppose, let's say I'm teaching this particular subject of optimization technique. Suppose I'm teaching this particular subject right now. So I will be having ready materials with me. I know what I need to teach everybody. I'm teaching this particular subject since last 2 years. So same thing, and this is my third year. So definitely I will be having adequate material with me. The sufficient information I will be having. Now suppose the another faculty comes and starts teaching this subject from the next year. Suppose I am not teaching this particular subject from the next year and another faculty comes and starts teaching this particular subject. Then what that particular faculty will be telling that, okay, this is my first year of the teaching this particular subject and you are teaching from last 3 years. So can you please provide me with your material so that I can use it for my reference? So that particular faculty will be asking me for the reference material. So I will be giving that particular faculty the reference materials. I will be giving that particular faculty all the assignments, all the documents, all the corresponding reference materials, all the supplementary materials or the supporting documents. So what I have done this thing, I have learned all these things by my own self. I have practiced it by my own self. I have teach you till now. Now I am transferring that particular documents. Now I am transferring that particular resources to some another faculty. Now I won't be teaching that faculty. I won't be saying that, okay, dear sir or madam, you please sit in front of me and I will be teaching you the entire course. No, I won't be doing that. I will be only transferring the documents to them. And it's now the role of that particular faculty to learn from whatever I have given the materials. So that is what we mean by transfer learning. We are not actually teaching the developing model, or the well-developed model is not teaching any developing model, but we are only transferring the things that has been learned from one model to another. And from those things that has been transferred, the developing model will be starting to learn by itself. So that is the process of transfer learning. Okay, so we were in the stage of AI. So why we are using AI? We are using AI because we want something to be done automatically by the robot. We want the prediction. We want the prediction. Now this prediction is nothing but, suppose if I'm saying that, okay, today the atmosphere environment is 29.5 degrees Celsius. Suppose I'm saying one model will be saying, one of the environmental model will be saying that, okay, this is the original temperature. One model has predicted the temperature 2 days before, that on 6th of the September, the temperature will be 28 degrees Celsius. Model 2 has predicted the temperature that on the 6th of the September, it will be 29 degrees Celsius. And model 3 has predicted the temperature that, okay, on 6th of the September, it will be 30.5 degrees Celsius. Let's say I've developed 3 models. Which model is correct in its decision, or none of the model is correct, but which model is more reliable or is more trusted out of these 3 models? Anybody? Have you got the question what I'm trying to ask? Correct. It will be model 2. Why? Because the original is 29.5 degrees Celsius. Model 1 is saying 28 degrees Celsius. Model 2 is saying 29 degrees Celsius. And model 3 is saying 30.5 degrees Celsius. They all are giving the predictions. They all are giving me some output. They all are giving me some output. But why I am saying model 2 is more reliable or is more accurate? Can anybody just give the answer for this thing? Why model 2 is more accurate? Right. Prerna is correct that it is near to the approach of original answer. So it is near. So whenever our quantity is near to the original answer, let's say near to the original answer, that means if I would be performing this particular subtraction, original minus predicted, these are all my predicted values. I can write this all to be the predicted values. The model have predicted these values. Now if I'm writing this particular thing, original minus predicted, then I want this particular difference to be less as possible or as low as possible. I want this particular difference to be as smaller as possible. And what do we mean by the smaller difference? I can write this difference to be the minimum difference. I want this particular difference to be as minimum as possible. What is this minimization? It is nothing but the minimization problem. It is the minimization problem. What is this particular thing? It is nothing but the minimization problem, and minimization problem deals with the optimization, which we have already seen. So you can say that yes, this type of the questions of the prediction works on the basis of the optimization. Works on the basis of the optimization. Work done by robot, the second thing. So I want the robot to do certain work. Let's say I am asking the robot to just fetch some information for me. And I want this robot to work exactly as what I informed the robot to do. Now the exact working may or may not be done. But at least I will be expecting that, okay, if the robot is not working exactly, then at least it should be working to what near working of that robot should be, to what the task that has been given to that particular robot. So this is nothing but again the minimum difference in what was been expected and what is been done. Same thing, find patterns. Find pattern. What is this pattern? So if I'm saying that, okay, the pattern of the object, let's say I am feeding the model this type of the input. Let's say this is the input over here. This is the shape, the input of the shape. Then it will be over here, something like this. Or I don't know, they are all looking the same because of the drawing. Something, let's say like this. Okay. Then what will be my next thing? What will be my next output? This is nothing but the pattern. It will be certainly, the model will be trying to understand that, okay, it is nothing but rotated by 90 degree minus 90 degree. Then it will be something like this one in the next step. If I'm saying that, okay, my output is this one, or my sequence is this one. So what will be my next sequence? If I'm asking the machine to predict, this is also a pattern. This is also a pattern. Now the pattern is not necessarily numbers, or it is not necessarily a diagrammatic thing. It can be anything. Pattern in the video, pattern in the image. So it is nothing but the model will be saying that, okay, the difference is in between them, it is 1, in between them it is 2, in between them it is 3. So the difference will be 4 and my predicted output will be 11. So what does this thing mean? I want my model to predict this particular value is close to 11. That is approximately 11 is close to 11. That means the difference is minimum. Minimum difference. Same thing if I am saying that, okay, I have developed the model for something, let's say stock market prediction. I have developed the model for the stock market prediction. I will be taking one of the stocks. Let's say I will be taking one of the stock, let's say XYZ. Now this particular stock, if it is trending at, let's say, rupees 350 currently, then my model will be saying that, okay, you please purchase this particular stock so that you can have, let's say, around 420 price in the span of 7 days. Then this particular model is predicting this particular value 420. Now I will be very glad if the model works in this particular direction, if the reality works in this particular direction. Why? Because it is giving me more and more profit, rather than decreasing the value from 350 to near to, let's say, 320, 330. I will be more happy if this particular trend works in the positive direction and reaches 420 or around 420. Then what is the intention over here? The intention is to get the profit. Why the people invest in the stock market? To get the profit. That is the clear intention of everybody. None of the people will be investing in the stock market to lose the money. Everybody will be investing with the intention. I am saying about the intention to get the profit. So what is the profit? Over here, our intention is to maximize the profit. So this is what it is, the optimization technique. Maximization is the optimization technique. So whatever you will be developing, whatever task you will be performing are all dealing with the optimization. Whatever thing you will be doing in your real life are all developed based on the optimization only. And hence this particular subject is being introduced as a preliminary course or preliminary requirement to the subjects of ML and AI. So you'll be seeing that, okay, from the next semester, you will be exposed to the course of ML, and in the further next semester, that is in the 7th semester, you will be exposed with the course of AI. Why you are learning this in the 5th semester? Because it is nothing but a preliminary course to ML and AI. You will be facing today, or you will be just having some notion in your mind that, okay, how the assignment problems will be used, how the transportation problem will be used. But now probably you can just interrelate this thing, that there are different types of the things. Transportation problem doesn't deal only with transportation of a particular product from one factory to a particular outlet. No, it doesn't mean that thing. The name transportation is given based on that particular phenomenon, but it can be used in the interrelated problems also. So these are the type of the things that you will be facing in your real life. The nonlinear optimization. Nonlinear optimization. Okay, now, fine. So till this point of time, anybody having any doubt? Anybody having any doubt? Have you got the thing why the optimization is important? Why this particular course is important? Nevertheless, we haven't have a discussion on the non-linear optimization, but I have just interrelated the course optimization with this particular field of ML and AI. I have just tried to maintain the sync in between this field. Why we are learning this particular course? Is it like the course was being put just as it is? No. Why we have introduced this particular course? What is the purpose of introducing this particular course? If you just look for the course structure and compare with the course structure of ICT, then you will be finding why this particular course has been introduced. What is the purpose of this particular course? You will be just having the thing in your mind that okay, why we are knowing the importance of optimization, why we are learning about the importance of the optimization in the mid of the semester, when the semester is already completed or it is already at 50% of the way. Why? Because now you are quite mature enough to know what is minimization and what is maximization. If I would have taught this same concept in the very beginning, in the very first orientation session, then you just had no idea about minimization and maximization. So you will be just nodding your heads, yes sir, whatever you are saying is correct. You cannot have the feeling that okay, yes, whatever we have done is interrelated in this particular manner. So that is the reason I am explaining it in the midway. So is the thing clear why we are having, why optimization is the first step towards this particular field of ML AI? Anybody having any doubt? Okay. So let me just give some hint about nonlinear optimization, and then we would be just ending the session. So by the end, I will be just telling, I will be giving one example to solve, and you will be solving that particular example. Okay. So that example will be given as a part of the homework. Right. So in the nonlinear optimization, what we have done in linear optimization, if you remember the linear optimization, we were having the objective function, which was having the degree of polynomial to be 1. Now, what is the degree of polynomial? If I'm saying that, okay, you are having the objective function, this one, then the degree of polynomial is 1. If you are having the objective function of, let's say, this one, then you are having the degree of polynomial to be 1. If you are having this type of the objective function, then you are having the degree of polynomial to be 1. But if you are having this type of the structure, then your degree of polynomial will be 2. If you are having this type of the structure, then your degree of polynomial will be 3. So in your linear programming problems, we have always dealt with the degree of polynomial to be 1. If this is the objective function, or even if you consider any of the constraint like this one, then the degree of polynomial will be 1 in any of the case that you see. But in nonlinear programming problem, the degree of polynomial for objective function will be greater or equal to 1, and the degree of polynomial for constraint can be greater or equal to 1. Now, why I have written greater or equal to in both the things, it doesn't really mean that both the things should be greater than 1. You can even have the degree of polynomial of objective function equal to 1 and degree of polynomial for constraint greater than 1. or degree of polynomial of the objective function greater than 1 and degree of polynomial for constraint equal to. Or third case can be degree of polynomial of objective function greater than 1 and degree of polynomial for constraint greater than 1. So both can also be greater than 1, or either of one can also be greater than 1. So in the nonlinear programming problems, you can have this particular scenario that your degree of the polynomial of the objective function or the constraint will be greater or equal to 1. Depending on the scenario, you can have this type of the thing. So when can we term the entire problem statement to be of the nonlinear programming problem? By this particular fact, that either of the objective functions or the constraints or both have the degree of polynomial to be greater than 1. So that is the thing that you should be keeping in mind. And that is the reason we are learning nonlinear objective functions. Now, I won't be saying anything else about this particular nonlinear objective function as of now. I will be simply giving you one question to solve, and you will be solving it and coming in the next lecture with the solution of this particular question. I would be recommending everybody to just write this particular question. Your objective function is to minimize x1 square plus x2 square. Subject to constraint. Subject to constraints. X1 plus x2 greater or equal to 4. 2x1 plus x2 greater or equal to 5. X1 and x2 greater or equal to 0. So these are your constraints. This is your objective function. This is your objective function. And these are all your constraints. Solve using graphical method. Now this will be the revision for your exam also. You need to solve using graphical method. So what we were doing in the graphical method, quickly let's have the revision. You will be drawing a two-dimensional graph. Why? Because we are having over here the two variables. So the number of variables are resembling to the dimensionality of the Cartesian graph. So you will be doing drawing this particular two-dimensional graph. You would be plotting this particular set of the lines by just equating the non-equality to the equality. Let's say x1 plus x2 is equals to 4, and this will be 2x1 plus x2 is equals to 5. So the points will be 0, 4 and 4, 0. So somewhere over here, and over here your points will be, if I am putting 0 over here, then it will be 5, and if I am putting 0 over here, then it will be 2.5. So somewhere like this one. I don't know whether I have drawn correctly or not. No. 0, 5, so it will be over here. So somewhere, I don't know how it will be looking like, but you can just have it something like this. So you can just draw it in the Cartesian axis, and you will be having the feasible region. And from the feasible region, you can find the corner points, and from the corner points, you will be having the corner point solution. Corner point solution. And then you just put this corner point solution into this particular thing, or the corner points into this particular thing to obtain the minimum value. So everybody will be doing this question using the graphical method, and you will be coming in the next lecture with the solution. Is the task clear to everyone? We would be just looking into how the things completely gets changed whenever we are discussing about the linearity and whenever we are discussing about the non-linearity. how these particular things will be similar and how the things will be different. So we'll be just having a discussion on that. And from this particular discussion, we will be also moving towards the concept of gradient descent. Probably many of you would have heard about this particular method, a very important method in the field of AI. The AI field just developed based on this particular approach. This is the optimization approach, gradient descent optimization. So we will be leading our discussion to this particular method, gradient descent optimization. But for that, it is very important to solve this type of the questions to understand the reality. Okay, so that's it for today's session. Anybody, if you are having any of the doubt, then you can ask me, else you can just write your roll number and name in the chat box and you can leave the session. I hope you will be doing this particular question and prepare well for the exam. Start preparing for the exam. Don't wait for the time to get declared that when the exam will be.